So hello everyone. So today we are going to work on how to generate terrain and how to run the code that is responsible for calculating the vertices and triangles and everything, and run it in a background thread, so rather than doing it in the main game thread. At the moment everything is happening in the main game thread. We have converted it into C++. Now you may have seen a small drop of FPS if I enable stat unit graph. You can see a sudden increase in the unit graph that you can see in the bottom left when a new component is being added. You see there was a FPS drop. So yeah, that's what we are going to work on today. How to use a background thread to do the calculations rather than doing it in the main thread, and hopefully we would be able to gain some performance improvements. And before we get started, as always, I'd like to remind you, you can download the project files of this project and all other thousands of projects that I have done in my channel. So I'll leave the link in the description below. Once you become a member in the Patreon page, you can download anything without a limit. So that would help me to continue doing what I do here. Okay, so back to the tutorial. Now, so this is the code that we implemented yesterday to calculate the triangles and everything, and add the mesh section to the procedural mesh. So here, generate terrain, this is the function that do the main workload. Right, so now to implement multithreading, we need another class based on if non-abandonable class. So I'm gonna call this class Async terrain generator, extended from public if non abandonable task. Right, and here, just like in the previous class, we need there are few functions, that mandatory functions that we need to implement in order to implement multithreading. Now here, public and private sections. So in the private section, I'll define a variable, a world generator, a pointer to the world generator, world generator, and let's set a constructor Async world generator, oh sorry, not world, terrain. Hold on, I should have used the word here instead of terrain, so that makes it less confusing. So let me delete that and rename, because I'm using a world generator for the previous class as well. Okay, so code wise that only the name, no logic wise any change. Right, Async world generator, and we need to give this reference a world generator pointer, pass it as in world generator, and sorry, not a word, this should be just world generator, because this is this pointer, this variable, and we initialize with what we pass here. Okay, so when we run the thread, this what we passed into the function, this pointer will be assigned to this pointer. Okay, and there is this part, first line is stat id get id, sorry, get stat id. So I haven't really looked in depth into what this part exactly does, but so I'm just copying this. So return quick declare cycle stat async world generator stat group thread pool async task. So yeah, I'm not 100% sure what's going on here. Maybe you should look into that. Okay, and finally, do work. Void do work. So this is the function where you write the actual code that you need to execute inside the thread. Okay, and that's the only thing we need to implement also. Now here, since I already have a pointer, we can actually do this. Word generator, and but here we don't know which section index to give. So therefore, let's do some modifications to our original code. So this is the direction that we are going to go, but we need another function to actually start this do work function in a separate thread. So for that, in the world generator, I'll add another blueprint callable u function void generator async constant. Let me just copy. Right. Okay. So I'll have a different, make a little difference. I'll call this in section index, and let's implement this function here. Okay. Okay. So now here I'll add another two variable under where it can be with a public property. We don't need to expose them into blueprints, so int section index x and int section index y. As default values, I'll keep 0. Right, now this may be a little unclean, but we can refactor later. So here section index x, I'll store in section index x and section index y, store in section index y. Okay, now to start the thread, we can use this way. Async task named threads any background thread normal task and here, right, so within this section we can start our thread. So auto world gen task equals new async task. This will be the type of async world generator, and here we need to give this reference. We need to pass that here. So we need to basically give a reference to this world generator. So that means this. So, and this throws an error. That's because we need to define what are the parameters that we are going to pass. So if I add an, this goes away. And basically means, as I remember, like we can pass all the references or something. I don't exactly remember, sorry about that. So but you can look it up. Right, now we can start this world gen task, start background task, and world gen task ensure completion, and delete world gen task. So once we complete, we need to delete that task, and that's the end of, that would be the end of this thread, not thread, this task. Now once when we start the background task, what happens is it's going to start this do work in a separate thread. So now here we can uncomment this, but still we need to pass the parameters. So we already have these parameters within this class, so therefore we can actually remove this. But if I remove this, I will not be able to pass these values in the blueprints here like this, but I need to keep that function as well. So therefore I'm not gonna remove them. So I'm gonna simply use set is world generator section index x and world generator section index y. Okay, so here I know there will be a problem with this part. when we create mesh section for the terrain mesh, this is going to throw an error because usually U objects or game related objects should not be modified in other threads. They should be handled only in main threads. If not, we run into errors. But anyway, let's try this and see what happens. And also we need to make sure we don't have any errors. Okay, hides class member, right? Because here we have this section index X input parameter and this. So I'll rename this one in section index X in section index Y. And here why didn't rename? Okay, save and recompile. Okay, done. Alright, now here, yeah, this is expected. But anyway, we are not going to use this now. We are going to use generate terrain async. So this one, pass X and Y. Alright, let's see what happens. So yeah, as I said, we ran into an error. Is unlocked. So here you can see procedural mesh component. So word generator CPP 123, line 1 2 3. Yeah, this part exactly. Okay, so let me close this. So now instead of creating the mesh here, let's only do these calculations in the thread and do the creating mesh part in the main thread. So in order to move this create mesh section part outside here, we would need variables to hold this data. So subvertices, subtriangles. Okay, so here, so TRA refactor subvertices. And just like this, we need sub-UVs, subtriangles, and subnormals. Right, I just type them. So now we have vertices, UVs, triangles. Okay, now here, we have also defined them here as well. So I'll just comment them because we have them defined, we have moved them here. So now what we should do is, let me just do that. This part need to move out, so let me cut. No, let me cut that, and here I'll add another function. Should be a U function. Oh, hold on. Let's define the function first. I'll call it void for type. And inside here, let's move this part. So here what happens is, drawing or actually creating the mesh section for that landscape tile we just generated the data for. But how do we know that it's ready to draw? So for that, let's add another variable. Well, I think we need two variables. So your property, flow print read write. Maybe it's just a read only. We don't need to edit it. So pool generate let's see, default value will be false. So we will be using this to determine if we are currently generating some tile. If this is true, we should not attempt to generate another tile again. And also another boolean variable, tile data ready. Okay, now when we start this async task here, no, maybe let's do that here. Generate BC. I set it to true, and then when this data generation part is complete, I'll set tile data ready to draw. Okay, now once I draw the tile here, I'll set generate BC to false and tile data ready to false. I'll do that. I'll do this right before creating a mesh section. Oh, sorry. This should be moved. And one more thing. Before we start writing the next tile, I'll delete this. data. So subvertices empty and subnormals empty. And actually these sub triangles we can keep it because each tile has the same number of vertices, so therefore this is identical for all the tiles, so we don't really need to recalculate it for every time. So therefore I will not empty that. Subnormals subview is also empty. Maybe subview is also we can keep, but subtangents. And now where to be here? Subset triangles. If sub triangles no equals 0, only then we should recalculate this. And we can actually avoid this part too, but let's just see if this method is working first before doing any further modifications. So we need to bring up the project. Okay, now here we generate the terrain. So spawn tiles around player. Here now we can use generate basic. If this is true, we should not run this. If this is false, we should attempt to generate terrains. One more thing. Here we should only do this once. Actually, we can't do it like this now, because this is, we are inside a for loop, so this is obviously going to be called multiple times. So instead I'll do it like this. Now here we add a tile to be generated, and instead of adding this mesh section, I'll make it -1. That means this, we need to generate this tile, so we are like queued to generate this tile, but it's still not generated. That's the idea here. Okay, so then once this follow-up is completed, here I'll get this generated tiles. Maybe we should call it queued tiles, because that's more appropriate. Queued values, and then keys run a for each loop with break. So here, if the element is less than 0, that means -1, that means we need to generate this tile. So using this index, we can get this point, and then we can call this function generate tile async. So we have the x coordinate here, y coordinate here. So now we are going with each tile one by one. Also, once this condition is true, we need to break this for loop. So okay, and also for these cube tiles, now we need to add the same thing, but now I'll make the value 1 or mesh index. Get mesh section index, right? So that's initialized now, and we need to use the same. Oh, sorry, maybe we should recombine this, right, and then break it here. Okay, alright, so that's the generation part. What about the drawing tile, draw tile function? So that could be called here. If the generator is busy, now we can have a branch to check if tile data ready. If yes, we can call draw tile function. Alright, now I think now this should work. Let's see. Yeah, it's generating part by part, but we are already down inside here, so we can't see. Yeah, so I'll make this is player start. Let's make a platform for the player to see the world generated. Player start, I'll copy the location to the cube. Right. Move it under. Make it a bit bigger. So player can stand on it. Okay. Now you can see the tiles are generated. Yeah. And I think we didn't encounter much of a performance hiccup. Start. Wow. Okay, let's do some traveling. Oh. Okay, so it's better, much better than before. But I wonder would that stay the same as we keep adding more and more tiles. Yeah, it seems acceptable enough. By the way, this is the end of the water plane. It's just a plane that I had added, so I haven't made it expand infinitely. But yeah, now it seems things are working pretty well. So here you see the hiccup of this performance drop stays within this region, which is much better than what we had before. Earlier it was like going here. Okay, so I think we can stop this episode right here. But still, this is not quite where I want it to be. We can still see the edge. Obviously that's because I want to keep it that way so that we can test the system, but I want to make it feel seamless so the player will not see the edge. So let's look into those things later on in this series. So thanks again for watching. As always, updated project files will be available for you to download in the Patreon page. Link would be in the description below. And see you in another episode. Goodbye.